Hello everyone, I'm Yogesh Hachi from Department of ISC. So today I'm going to demonstrate the project that is finding the minimum cost spanning tree using the Prim's algorithm as a part of the experiential learning for the course Design and Analysis of Algorithms. So before getting to the video, I'll just briefly explain you about the project title, which is the Prim's algorithm for computing the minimum cost spanning tree of a graph. So basically the minimum cost spanning tree is it is a subset of all the edges connecting all the vertices with no cycle and with a minimum cost edges, with a minimum cost possible edges. So this Prim's algorithm works under the greedy approach. So basically what the greedy approach is, the greedy approach, um, it's an optimization technique that makes a locally optimal choice at each and every iteration for with a hope of finding the global optimal solutions. So yeah, with this basic knowledge, I'll just demonstrate the video, demonstrate the project now. I'll just first share my screen so that you can see also. Wait. Yeah, I'll just I'm just going to the project folder. So here to implement the project, I have used the React.js, which is a front-end JavaScript library for building the user interfaces, and I have used the D3 library, which is the most powerful tool for building or implementing the dynamic and interactive data visualizations for the graph algorithms. And apart from that, I have used the HTML, okay, as usual for creating the web pages structures, and have used the CSS for styling the websites. Yeah, I'll just yeah, I'm just now start the environment or run the project. To run the project, I'll just enter the command npm start. So what this command will do is, so it will start the React development server. As I'm using the React.js, it will start the development server for the project environment. So here I'm using the command like npm start. Npm is a node package manager for the Node.js applications. Yeah, this is our main dashboard. So here you can see so many modules we have included. So here we have meet our team or the contact page, which is used for any clarification or any additional support for the users, so that they can contact our team for any clarification and any additional support. So the next module we have included here is that is a quiz module. So the application have an interactive quiz module to test the user's understanding of the Prim's algorithm and reinforce their learning. So this is a very comprehensive quiz module. So we have included, and the next one is a comprehensive documentation, that is the algorithm. So in this module, we have included the detailed documentation, including the theoretical background and step-by-step explanations, pseudocode, how the Prim's algorithm works, what is the implementation of the Prim's algorithm to finding out the minimum cost spanning tree, and the practical applications of the minimum cost spanning tree. Yeah, now we get into the real-time visualization of the Prim's algorithm. So this is the Prim's algorithm visualization board. Here you can see um, so many widgets and so many modules are there. So here we also provide the customizable graph visualizations. So here you can see the users can be able to customize the graph by setting the various vertices and edges, enabling the exploration of the different scenarios of the graph structure. The user can able to change the topology of the network, topology of the graph, and they can change the number of vertices and the vertices names also. So after that, with the help of the adjacency matrix, so they can change the topology of the network, the connection between the two nodes in the network. And usually for Prim's algorithm, it enables us to finding out the Prim's algorithm with any given starting vertex. So I have given the starting vertex. I'll just now run the project. Firstly, I will set the number of vertices as 6 itself. And yeah, the vertex name is ABCD itself I will give. So we just have to click on the set vertices button to set the vertices. Here you can see in the dashboard visualization board. So the vertices are ready to for the graph. So the here I'm setting the adjacency matrix, and that means I'm connecting the adjacency. I'm connecting the nodes between the nodes. So you can see here. So I have add the values 0, 1, 3, 0, 0, 3. So if you provide a 0, it will just ignore the connection. It will not connect the two vertices between the it will not connect the vertices. So if you give the word if you give the positive edge only, it will connect the vertex from one node to another node. It will establish the edge from one node to the another node. So we'll just click on the set matrix to make ready the graph. Here you can see that in the visualization mode, the graph is ready to perform the minimum cost spanning tree, which is a Prim's algorithm. I'll just start with the vertex A itself and you can click on the set vertex to set the vertices. So after creating a graph, you just have to click on the run Prim's algorithm to run the implementation of the Prim's algorithm that we have developed in the project. So I'll just click on the run Prim's algorithm. So here you can see it is showing the step-by-step implementation of the Prim's algorithm, how the edges are selected to finding out the minimum cost spanning tree at each and every iteration. So here in the right hand side, you can see in the green color. So I have implemented that. So in the iteration what is as usual, since I'm starting the vertex with the vertex A. So it is selecting the edge from vertex A to vertex B with a weight of 1. So after that, once it goes to the vertex B, it will select the edge from vertex B to vertex D again with a total weight or the cost with 1. So once it goes to the vertex D, so the next minimum edge is the vertex D to vertex D, vertex C with a weight of current 2. So the current, you can see here, the in the right hand side, you can see at every iteration what is the total MST weight when it is as it is traversing or exploring the nodes from starting vertex. So after exploring the node C, so it will just explore the node E, and after E, it will select the edge from the vertex A to vertex F with a minimum cost of 3. So this is how it will show the implementation or each and iteration wise implementation. And after running this algorithm, so you just click on the show MST if you want to see the visualization of the Prince algorithm, like what is the total the final minimum cost spanning tree of a graph of this graph. What is the minimum total physical uh, minimum spanning tree of a graph? I'll just click on the show MST. So here you can see this is the total or the final spanning tree of this graph, which we have seen in the graph. So this is the spanning tree with a total cost of 8. So here you can see it will first select the edge from A to B and B to D, and then D to C, C to E. After that, it will select the edge from A to F. Yeah, this is the Prim's algorithm, how the Prim's algorithm works, and the visualization of the Prim's algorithm for computing the minimum cost spanning tree of a graph. So yeah, this is all about our project demonstration. So here we can also improve we can also speed up the process or implementation with just clicking on the buttons here. And you can also clear the vertices, the dashboard by just clicking on the clear vertices button. So once we clear, it will just remove all the implementation or the current implementation of the graph. So yeah, this is all about the visualization or the real-time visualization of the graph algorithm. Thank you.